Okay, hi again. We are going to do some review from chapter 6. First question of this type, question 6 that I had, question 6 from the list of our questions was find the area 6a, find the area between y is equal to sine of x, y is equal to e to the x, x equal to 0, and x equal to pi over 2. With the area calculation, it's always a good idea to have a picture in front of us. Exponential of x, you remember from beginning of semester, exponential of x looks like this, and sine of x. So we want the area between these two, and it's obvious that the blue curve is the top, the exponential is the top here. We are starting at 0 and going as far as pi over 2. Here's pi over 2. The area we are calculating is the area in between these two. The style of calculation is to calculate the area of each of these strips. So you calculate that and just add it up. You sweep the area from the left to the right. So the area we want to calculate is going to be each of these things has a width dx. So dx is how wide this thing is. The height of it is the top curve exponential of x minus the bottom curve, that's sine of x. That's the height, this is the width. You multiply and then you want to add them up. Addition is going to be done by integration. You are starting from 0 and going as far as pi over 2. Antiderivative of exponential of x, exponential of x. Antiderivative of minus sine of x is cosine of x. And then I have to plug 0 and pi over 2 in this. At 0 I have exponential of pi over 2 plus cosine of pi over 2. At 0 I have exponential of 0 plus cosine of 0. It's exponential of pi over 2 plus 0 minus 1, and becomes exponential of pi over 2 minus 2. And that is the final answer for this one. Next one, a bit more complicated, problem 6b. Area between y is equal to x cubed minus x and y is equal to 3x. Again, a picture is not absolutely essential, but it would be rather hard to see what's going on without the picture. Exponential of x cubed minus x, what's the picture of that? Well, you go ahead, find the x-intercept of it. It's like 0, 1, minus 1, 0, and 1. The graph, you quickly graph this thing. It's going to start from the third quadrant, something like this. This is x cubed minus x, and y equal to 3x. This is y equal to 3x. We want the area between these two, which is obviously this area. As you see, the picture is symmetric. If you just subtract these two these two functions and integrate from one end to the other end, they'll just cancel each other and you get 0. So the problem is asking for the physical area. That is, imagine you're having a cardboard perhaps cut in this style, say to make a propeller or something, and you want to find out the net area. That means you have to calculate that area and this one and add them to each other. Okay, without the picture, what would we have done? Without the picture, we would have taken these two functions and set them equal to each other to find the points of intersection. We want to find out these. If we don't have the picture, we still need these points. So what do? X cubed, bring everything to one side, factor set it equal to 0. So here are the point of intersection. We have one point of intersection here at -2. We have another point of intersection at 0 and another point of intersection at 2. So what does that tell us? 3 intersections. -2, 0, and 2. What that tells us is that when we want to calculate the area, we have to do our additions separately in each portion. Like here, choose a color. Suppose you want to calculate the area here. What do you do? Height times dx. Well, the height here is blue minus the purple. But here, the height is calculated as purple minus the blue. So when you have the picture, that's the advantage. You can right away go to you say formula for the top is x cubed minus x. Formula for the bottom is minus 3x. You subtract these, you get the height. Multiplied by dx, that gives you the area of one of these strips. Then you add it. Add it from where? Add it from the first to the last point, like -2 to 0. The other piece you calculate separately, because here 3x is on the top and the other one is on the bottom. The second strip goes from 0 to 2. Now what would you do if you didn't have time to draw the picture carefully? Well, you will still have to go find these intersection points. Comes the question, who is on the top, who is on the bottom here? Well, if you make the wrong choice, all that happens is that the result of integral is going to come out to be negative. And the simple way to cure that is just to strip the negative sign away. So if you don't want to spend time figuring out the top and bottom of the region, just randomly assign it and go ahead with the business of integration from one intersection to the next one. If that result came out to be negative, means that you have made the wrong choice for the top and bottom and you had to reverse it, and you get the answer anyway. Okay, so we just go ahead. This is the integral from -2 to 0. This is x cubed minus 4x dx, and the other one is just going to be negative of this. When you subtract, this is 4x minus x cubed dx. So whatever effort you spend for integrating it here, most likely it's useful on the next integral as well. So this one becomes x to the power of 4 over 4 minus 2x squared minus 2 to 0, and then we have 2x squared minus x to the 4 over 4, and this one goes from 0 to 2. So you just plug the numbers in. So at 0 we'll have 0, nothing to do. At -2, this was -2. At -2, this is going to be 4 minus and 8. And now if I plug 2 in this thing, it is going to be 8 minus just like what we obtained over there. In this symmetric picture, so it turns out that these two contributions are the same. This is 4 and another 4. We get the area is 8. Okay. Problem 7 is beginning of calculation of volumes. We want the volume of a region between y is equal to x4 and y is equal to 1 to be rotated around y equals to 2. Quick picture here again. X to the 4 just looks something like this. This is y equal to x to the 4. This is y equals to 1. So the region we are interested in is this region. We are going to rotate this thing about y equal to 2. This is the axis of rotation. So we're taking this picture and turning it shape more or less like that. Okay, how do we find the volume? Easiest way to go about it here is to use the method of washers or rings. So we are going to use the method of washers. If you take any of these slices, this picture is rather crowded, but here's one slice. There is a inner uses so one of these slices looks like this washer. How do you find the volume of one of these washers? Well, we are going to have a thickness. The thickness we are going to write it as dx because the washer is perpendicular to the x-axis. We are going to take the outer radius. How do we find the outer radius? Radius is the distance from the curve itself to the axis of rotation. This is 2. This is x to the power of 4. So that radius is 2, the outer radius is 2 minus x to the power of 4. From here to here is 2 minus x to the power of 4. Area of the circle generated by rotating this is pi times r squared. This is r squaring that is going to give me the radius, and then I have to multiply by pi to get the area. Pi times that is the area times the x is going to be the volume. Then I have to integrate that. Now here it turns out that we have an inner radius as well. We are removing the inner core. What's the radius of inner core? Radius is a fixed radius. It's just 1. The radius of this, let's draw it with this color from here to here. The inner radius is just 1. So 1 squared times pi is going to be the area of the inner circle. I have to subtract these two from each other because the inner portion is removed. Then I have to integrate. Integrating, well, I leave it to you to find out that the point of intersection here is -1 to 1. So we are going from -1, and here the this becomes the integral that's going to give us the volume of this object. You go ahead and clean up this integral and calculate it from -1 to 1. 2 squared is 4 minus 4x to the 4 plus x to the power of 8. x4 squared is 8, and then you have to subtract 1. That is equal to pi. 4 minus 1 is 3. Antiderivative is 3x. This is going to be 4x5 over 5 plus x9 over 9. The whole thing has to be multiplied by pi. Now we go ahead and pi here I plug 1 in this, it's going to be 3 minus 4/5 plus 1/9, and then plugging minus 1 in it, all negative, minus 3 plus 4/5 minus 1/9, and that is pi. Now we are going to be doubling up, because this negative or negative makes positive. Instead of 3 you're going to have 6, and instead of that you're going to have 2 of this. Here's a quick way of doing it. You just double one of these things, 3 minus 4/5 plus 1/9. So you take a common denominator here and find out what that is. 2 pi 45 times 3 is going to be 135 minus 36 plus 5, so that is 2 pi times, makes a total of 104, I guess, over 45, so 208 pi over 45, if I'm not mistaken, becomes the volume of this region. Excuse me. Now that was one problem from method of washers. Let's take a look at the method of cylindrical shells. We have first problem 8a, a region defined by the following: 3 plus 2x minus x squared, and y plus x equal to 3. So the region is bounded by these two curves, and we are turning it about y-axis. So what is a quick picture here? We have a general idea, if we can. This is a parabola pointing downward. This is going to be a line with negative slope. They are going to intersect each other and have a region defined that way. Then we take that region and turn it around the y-axis. Natural choice for calculating volume here is the method of cylindrical shells. We'll see shortly why. Okay, let's get a little bit of bearing about this function itself. What kind of a parabola is it? So let me just quickly draw it. 3 plus 2x minus x squared. So y-intercept is 3. If I set it equal to 0, 3 plus 2x minus x squared equal to 0, I'll have 3 minus x perhaps times 1 plus x equal to 0 is a factorization of this. So it is going to have one intercept at x equal to 3, another intercept at x equal to minus 1. For curiosity, if I put a 2 in this, I get 3 plus 4 minus 4. Here's 1, 2, and 3. I get the same height, and there's going to be some maximum somewhere in between. So parabola looks something like so. This is y is equal to 3 plus 2x minus x squared. The other one is faster. Y plus x equal to 3. That x and y intercept of it are just 3. So that thing is just connecting these two conveniently. So this is y plus x equal to 3. Region bounded by these two is this region. This is the region that is bounded by these two. We just noticed that the points of intersection are 0 and 3. You can verify that individual separately. We are taking this and turning it around the y-axis. So whatever this region is, so perhaps that didn't become a good picture, but we are in a rush. We have a region like this. We want to calculate the volume of solid of revolution. What do? We pick one of these strips, say at location X. See what happens to it is when it goes around. It creates a cylindrical shell here. What's the volume of cylindrical shell? We said take the circumference times the height times the width of it. So width of this thing is going to be dx. The radius is just x. If you start this the strip here at x, the radius is x, circumference is going to be 2 pi x times the height. What's the height? That's going to be the distance from the blue from the purple. The equation of the blue curve is this. The equation of the purple curve, we might write it that it's going to be y is equal to 3 minus x. When you subtract these two, the difference is going to be 3x minus x squared. So difference is going to be this height. You take the top one is 3 plus 2x minus x squared, and subtract from that the bottom one. So 3's cancel. 2x minus x is plus 3x, minus x squared is the item here. And then we have to calculate the volume. So the volume, you integrate from 0 to 3, and then you're all done. So how to calculate this? We better put the 2 pi outside so it's not crowded. This is 3x squared minus x cubed dx from 0 to 2, and that goes as 2 pi times x cubed minus x to the 4 over 4, and now we are between 0 and 2. This is 2 pi. Plugging 2 in this is 8. Plugging 2 in this one is a 4. 4 times 2 is 8 pi. Okay, so that was not that bad. Next problem here, problem 8b. We have a region that is bounded by x equal to 4y squared minus y cubed, x equal to 0. We are going to turn about x-axis. Well, again, a picture is going to help a lot. In this picture, you give values to y, get the values for x. That would be a smart thing to do. So here's x, this is y. Good idea would be to go ahead and find out a y-intercept of this. So if I set 4y squared minus y cubed equal to 0, y-intercept x is equal to 0. this factors as y squared times 4 minus y equal to 0. Roots of that are y equal to 0, 0, and y is equal to 4. We have a double root here, and a root, let's suppose 4 is here. So this is the graph of 4y squared minus y cubed. Now x equal to 0, of course, is just the y-axis. What is the area that's bounded by these two is this section. So I go ahead and highlight this section. Okay, we are taking this and rotating it about the x-axis. So when we are rotating about the x-axis, I don't, let's see if I can remove. When I rotate it about the x-axis, I will have a copy of this thing here. Let me show the rotation by another color. Here's we are rotating the object in this direction. So we want to apply the method of cylindrical shell here, and if you try to do it by discs, it's going to be very hard, because finding the radius is going to be, for a given x, finding the radius means finding y out of this equation. That's not going to be easy task. So it's better to consider a strip like this. When you rotate that strip is going to come here, and so all that you have to do is to find the volume of that shell. Well, for this shell, radius is y now. From here to here, radius is y. Circumference of this shell is 2 pi y. The height of this shell is x, but x is just this, 4y squared minus y cubed. The thickness of it is dy. This thickness is perpendicular to y-axis, is dy. All you have to do is to integrate this. Integrate from which point to which point? Well, our shells start from 0 and go all the way to 4. And that's going to be the volume. And so we have time to do this. 2 pi times 0 to 4 of 4y cubed minus y to power of 4 dy is 2 pi. First one, antiderivative is y4, second one is y5 over 5, and all you have to do is to plug 0 and 4 in it. That's 2 pi. I plug 4 in this, becomes 4 to power of 4 minus 4 to power of 5 over 5. When I plug 0, there isn't anything left to subtract. So 2 pi. We might as well be smart and factor 4 to power of 4. We are left with 1 minus 4 over 5. Notice how I'm avoiding to rely on my calculator too much here. 2 pi times 4 to power of 4, and this is 1/5. Now if you want to use a calculator, that's fine. 4 to power of 4, that's 256 times that 512. This is 512 pi over 5 about 100 pi. Okay, that is the answer to this problem. We go to the next problem, 8c. Our region is defined by y is equal to square root of x minus 1, y equal to 0, x equal to 5, and we are going to turn about y equal to 3. Let's see what's the deal here. Y equal to square root of x minus 1. That's a parabola that starts at 1 and opens rightward. So y equal to radical x minus 1. Y equal to 0 is just the x-axis. X equal to 5, some convenient place here. So x equal to 5. We are taking this and rotating it about y equal to 3. Oh, I didn't think about it. I should have drawn the picture lower, but that's fine. Here is y equal to 3. So we are taking this picture and turning it. So maybe I need to copy it up here from 1 to okay. Show the rotation by this yellow color. Kind of remember, this is the region. Let me draw some lines. So here's the region is this is the region that's turning around y equal to 3 and creating like the exterior of a funnel, and we want to find out the volume. And again, a good idea would be to use method of cylindrical shells, but in this problem using washers would be just as easy. If you slice it this way or you slice it by washers, same amount of work is involved here. So let's see. Volume is equal to, remember, you take one of these strips. If you're going by the washers, you focus on one of these strips, let's say this one, and remember we are turning this one around. So what do we need? We need to know, first of all, the easiest thing is how thick it's going to be. Well, we are going in the y direction, so the thickness is dy. What is the circumference of the circle? To find the circumference, you have to find the radius. The radius itself, remember, this is 3. This is the location y. This is some y here. 3 minus y is the radius. You multiply it by 2 pi, you get the circumference of the circle. One other item is left, is how tall is this? The height of it. This point is radical is the x and this point is 5. So that the height here, the height is 5 minus x. But I would better have the x in terms of y in this problem to be able to use it. So I go ahead and say, if I square both sides, I get y squared is equal to x minus 1. So x is equal to y squared plus 1. It's an alternate way of describing this parabola. So at this y, the height x is y squared plus 1. I don't want that. I want the distance from 5 to this point. So that's going to be 5 minus x, and instead of x I'll write y squared plus 1. So this became height, this became the circumference, this is the height, and this is the thickness. Our difficulty was finding height, and the main difficulty was to write it in terms of y. To do that, we had to go ahead and actually turn this equation around and write it as x in terms of y, so that I know this distance, and once I know that, I can find the distance from that point to 5 by simple subtraction. If I want to find the volume, I have to integrate this. Well, y's start at 0 at the low point, and when y is equal to when x reaches 5, what is going to be the last value for y? If x is 5, y becomes 2, and that becomes the last value of this integral. Again, if x is 5, I plug it here, and I get my largest value for y to be 2, so I go as far as 2. Now I have, let's put 2 pi outside, integral from 0 to 2 of 3 minus y times this is 4 minus y squared dy. Now you can continue this on your own. 0 to 2, I multiply it out, 12 minus 3y squared minus 4y plus y cubed dy, and that is 2 pi. So 12y minus y cubed minus 2y squared plus y 4 over 4 between 0 and 2. So that's 2 pi. This is 24 minus 8 minus another 8 plus, that's going to be 4. Okay, that's 12 times 2. It looks like we got 24 pi. Okay, if I made a mistake, I'm sure you're going to let me know. Okay, that would be the last problem I'm going to do today. I hope most of your solutions agreed with what I had here, or if I'm mistaken, you let me know. Good luck, and God bless, and I hope your test will come out to be in all flying colors. Goodbye.